So welcome students, welcome to all of you in this video lectures. Here I am going to start new chapter which is probability. So in the first exercise the concept of conditional probability is there. So I'll discuss on that what is the definition of conditional probability and what's its different properties. So let E and F are two events. Okay, let E and F are two events associated with a sample space S. Then the probability of occurrence of the event E when the event F has already occurred is called conditional probability, and it is denoted by PE by F, provided PF not equal to 0. So students, there are two events of a particular sample space S, E and F, and we are going to find out the probability of one of the event when the other event is already have done, right? So F is already have done, and now after that the second event is going to happen, and we are going to find the probability of the second event. That is called the conditional probability, which is written as PE by F, and its formula is P probability of PE intersection F divided by PF, where PF is not equal to 0, or PF by E is when probability of the event F when E is already done, right? Then it's equal to PE intersection F by PE when PE not equal to 0. So this is the definition of conditional probability. Now there are some properties of conditional probability, and these are: number one, conditional probability lies between 0 and 1. It is nothing but a probability of an event. So as we know that probability lies between 0 and 1. So the first property is this. Second property, probability of E intersection F by G, right? When there are three events in this type of probability, we can write like this: probability of E by G plus probability of F by G. Now the complement of probability, conditional probability, PE complement by F, which can be written as, can be find out 1 minus PE by F, right? So these are some properties of conditional probability. Another thing is multiplicative theory, and this comes from the conditional probability. Okay, and PE intersection F equal to PE into PF upon E. Okay, as I have discussed that definition of conditional probability is PE by F equal to PE intersection F by PF. If you cross multiply and you get the value of PE intersection F, this gives the multiplicative theory of probability, and this can be written as PE intersection F. Okay, PE intersection F can be written as PE into PF by E. Okay, also in case of three events, PE intersection F intersection G can be written as PE into PF by E into PG by E intersection F, provided PE not equal to 0. The students, these are some properties of conditional probabilities. Next, I will discuss about the independent events. When two events are said to be independent events, E and F are said to have independent events if PE intersection F is equal to PE into PF. If this condition holds, then we can say that E and F are two independent events. Now in case PE complement intersection F complement is equal to PE complement dot PF complement, in that case also we can say that E and F are independent events. Law of total probability. Suppose E1, E2, E3, En be the partition of sample space, and all E1, E2, E3, En are non-zero events, and A be any other events other than this set of events, then the probability of that other event can be find out using this formula: PE1 into PA by E1 plus PE2 into PA by E2 plus PE3 into PA by E3 dot 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 PEN into PA by EN. Using summation, you can write summation I equal to 1 to n PEI into PA by EI. So students, I hope all of you understood this concept of conditional probability and the other like events what I have discussed. Now I am going to explain few questions based on this concept. Okay, and this question based on your exercise 13.1. The first question is given that E and F are events such that PE is equal to 0.6, PF equal to 0.3 and PE intersection F equal to 0.2. We have to find PE by F and PF by E. So given probabilities are PE is given, PF is given. So we know that the formula for PE by F is equal to PE intersection F by PF. PE intersection F by PF, right? It is PF. So PE intersection F is given 0.2, right? It is 0.2 and PF is given 0.3. So 0.2 by 0.3, its answer is 2 by 3, right? Second one is given, we have to find out PF by E. PF by E is equal to PE intersection F by PE. So 0.2 by 0.6 equal to 2 by 6 is 1 by 3. So students, I hope all of you understood. The next question is determine PE by F when a coin is tossed 3 times. So student, the sample space will be the outcomes when a coin is tossed 3 times. Now the two events E and F are given. E event is head on the first toss, F head on the first 2 toss. Okay, head on the third toss. Sorry, E is even head on the third toss and F is the event head on first 2 toss. This is the first question. So here we have to find PE upon F, that is F is already occurred and we have to find the probability of E. Right. Now second question is E is given at least 2 head and F is at most 2 head. So let us start with the first one. Okay. So here when a coin toss 3 times, the outcomes will be this one: head, 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 HHT, HTH, HTT, TTT, THT, THH, TTH. So there are 8 elements in this set, right? Now E is the event head on third toss. So third toss, how many head comes? Let us find out from this sample space. Head on the third toss, right? Head on the third toss or tail on the third toss. Head on the I think it is tail on the third toss. The question is changed a little bit. It is question is tail on the third toss, right? So all the elements on the third toss tail comes HHT, HTT, THT, TTT, right? And the second, its probability will be 4 by 8. Probability of E will be 4 by 8. It is 1 by 2. Now second event F is given head on the first 2 toss. Head on the first 2 toss, so only 2 elements will come, HHH and HHT. So PF will be 2 by 8, 1 by 4. So what is the intersection of these two set? E intersection F, only one element, which is HHT. So PE intersection F will be 1 by 8. Now we have to find the probability of E when F is done. So PE intersection F by PF. So P intersection F we have got 1 by 8 by 1 by 4, which is 1 by 8, 4 by 8, which is 1 by 2. So this is the answer of this question. I hope students you understood this answer. The next question which is given that at least 2 head is an event at least 2 head. So at least 2 head, that means maximum 3 also possible, minimum 2 should be there. So at least 2 head, the elements comes HHH, HHT, TH, HTH, THH. So there are 4 elements, so P probability of this event will be 4 by 8. And at most 2 head, that means maximum 2 head, the 1, or if there is no head, then also possible. So HHT, THH, HTT, THH, THT, TTH, TTT. So all the elements, so there are 7 elements. So PF, probability of these events will be 7 by 8. Now the common elements P, E intersection F will be 3. So P, E intersection F will be 3 by 8. Now we have to find P, E upon F. So P, E by F will be P, E intersection F by PF. So P, E intersection F we have got 3 by 8, and PF we have got 7 by 8. So it is 8 cancelled, so answer is 3 by 7. So this is the answer of this probability. The students, I hope all of you are getting. Next question is, a die is thrown 3 times, right? The sample space will be the outcomes getting when a die thrown 3 times. The question is, E is the event 4 appears on the third, 4 appears on the third toss, or being third times, 6 and 5 appears on the first 2 tosses or first 2 thrown, right? Now when the die is thrown 3 times, we know that the number of outcomes will be 36 into 6 into 6, which is 216. Now students, how this 216 comes, I'll just give you some idea that when suppose we are keeping the first number 1 fixed, okay, and 1 1 1, okay, and the third die is changing 1 2 3 4 5 6, okay. In the second set, first is fixed 1, second is, here we are keeping 1, here we are keeping 2 fixed, third one is changing. So accordingly, here first is fixed 1, second last is 6 6, because 2 after the 3 4 5 6. So this is the one set, and this set containing 36 element, right? And similarly there are 6 sets will be there, because if keeping here 1 fixed, second one will keep 2 fixed, then third 3 fixed, like this we will change it and we will get 6 such sets will be there. So the total number of elements will be 36 into 6, which is 216. Now in the sample space there are 216 elements. Now E is the event 4 appears on the third toss. So these are the elements we can collect from this set. 4 appears on the third time, so third thrown, and there are 36 elements will be there, okay. And F is an element 6 and 5 appears respectively in the first 2 tosses. So 6 and 5 appears, these are the elements 651, 652, 653, 654, 655, 656. So there are 6 elements in the set F. So NF equal to 6, so P is equal to 1 by 6, because P is 36 by 216. After cancellation we got 1 by 6, and PF is 6 by 216, it is 1 by 36, and there is common element P E intersection F, right? P intersection F equal to 1 by 216, right? There are means only one common, 654, so 1 by 216. Now the condition probability P E over F, the formula is P E intersection F divided by PF. So 1 by 216 divided by 1 by 36. After calculations we got it 1 by 6. So students, I hope all of you understood these questions that I have discussed in these lectures, and also the concept of conditional probabilities theory part, and both the problems that I have discussed. In the next lectures, I'll discuss more questions on this chapter, and I'm ending today's lecture. If there is any doubt, you can contact me. Thank you very much.